didn't do nothing.
Still the answer to Mr. Scott's chemistry test.
Come on, no I didn't, bro.
It's not bro. It's bond. Carbon bond.
Holy
He's Carbon, a scooter-riding spy, a rather clumsy guy. That's Carbon, as sneaky as can be, an ace with a frisbee to a degree. Go Carbon, give all that you got, so you can stop Sigmund's plot. It's Carbon, he's double OC, an agent with a degree in chemistry. He's Carbon.
Double OC, stop embarrassing yourself with that pathetic intro.
But I have my own theme song. What's up, Paige?
Sigmund is terrorizing young couples with talk of addition reactions. Take a look at this.
What are you two doing? Why are you double bonded? Don't you know that's just setting you up for disappointment when it doesn't work out later? What is your deal? I'm just saying that this structure you guys have formed isn't very stable.
Huh?
This is terrible. Why can't they just hold hands? Who does this guy think he is?
An old science teacher, I believe. Trying to show that chemistry can apply to real-life situations. Hold on a second while I get my technical advisor. Hello, Double OC. I've got some new gadgets for this mission.
Like what?
Well, there's this special watch.
Awesome. What does it do?
It tells time. And of course you'll need these special shades.
Ew, these are hideous. I mean, look at mine. Mine are so much better. Do these do anything at all?
Nope.
Do I have to wear them?
You do.
Fine. Anything else?
Yes. And I've also got you this fluorine disc. It'll break down even the strongest of double bonds.
Thanks, H. I need to go stop Sigmund now. So how am I going to get there?
I've prepared a special vehicle for just this purpose. The Chem Corolla! This smooth vehicle is the highest rated safety vehicle around. Plus, it is equipped with rations. Plus, a rear guard. And it can go fast.
Thanks, but no thanks. I have my own ride.
What vehicle could possibly be superior to the Chem Corolla?
This one. It's a Chem Razor.
You're choosing this over the Chem Corolla?
Sorry, H. This is how I roll.
What don't you guys get about this bond you guys have just isn't healthy?
All of it.
Come with me then, to the chem lair.
What are we doing here?
I'm gonna educate the two of you if it kills me.
Want to leave us alone?
Okay, children, let's get started. Right now, you two are holding both of your hands, which is just like a double bond in a molecule. Over here, we see a hydrocarbon. The hydrocarbon is a hydrogen and a carbon combined in a molecule. Now, as we see here, this particular hydrocarbon is an alkene. An alkene is a hydrocarbon with a double bond between the two carbons. This double bond, which makes it an alkene, has both a sigma and a pi bond. The sigma bond is a bond that's parallel with the two carbon bonds. This one is much more stable than the pi bond. The pi bond is perpendicular to the two carbon bonds, so naturally it's less stable. Now, since the pi bond is less stable than the sigma bonds, we want to get you guys down to just a sigma bond. The best way to do this is by using an addition reaction. The addition reaction involves taking the two carbons and adding two bromines. We will do this by using my fierce carbon crew. This is my carbon crew and their hydrogen backpacks.
By adding a halogen, bromine in this case, we can break up the double bond between the carbon atoms in the alkene, forming a new molecule with all sigma bonds, which is much more stable. Our other option is adding hydrogen to the alkene, and we can also break the double bond. However, to break the strong hydrogen bonds in the H2 molecule, you must perform the reaction in a high temperature environment. This process is called a hydrogenation. A hydrogenation performed on an alkene will form an alkane. An alkane is a hydrocarbon with all sigma bonds, which is much more stable.
Like me, sigma.
Are you going to drown us in bromine or something?
Of course I'm not going to drown you in bromine. I'm going to bring in my carbon crew, and they're going to rip apart your pi bond and turn you into all sigma bonds.
How does this help?
Yeah, I still don't understand what the problem is. We're just holding hands.
Ignorant fools! Your pi bonds are going to react. We're going to turn them into sigma bonds, and it will be more stable.
Carbon crew, break their bonds. Put the sandwich down.
Oh no. What's
No.
going on?
Don't do it.
Oh, stop. Stop it.
How is that breaking their bonds?
Oh.
You fools, I told you to break their bonds and you go and add another one. Now we have a triple bond between the two carbons. This triple bond in a hydrocarbon is referred to as an alkyne. Note the I. I. Now we have one sigma bond and two pi bonds. If one pi bond wasn't bad enough, now we have two. This makes it extremely reactive, and it'll combust easily and create extremely hot temperatures. That's why alkynes are used in blowtorches. Carbon crew, break their bonds. Not so fast.
That's what she said.
You, carbon bond. I didn't think I'd have to deal with you after the cactus fiasco. Regardless, I don't have time for this.
Carbon crew, aromatic formation.
What's going on? What's aromatic? Glad you asked. The aromatic is a ring of 6 carbon atoms. Now, off of each of these carbon atoms is going to be a hydrogen. So it is again a hydrocarbon. This particular hydrocarbon is benzene. The benzene, as you hear the ene, is going to imply that there are double bonds. As you see, there are 3 double bonds. These double bonds and these single bonds are going to be a resonant structure. They're going to switch. These double bonds are going to switch back and forth. This is going to create sort of a shield that's going to go around. An electron shield of delocalized pi bond is going to create a stable field that is going to track you, and you will never escape.
Holy hydrocarbons, this formation is so stable I'll never be able to escape.
Right, now Bond, I have you right where you belong, in the center of an aromatic chain. Now, if you'll excuse me, my soap is on.
Oh no, Carbon. What are you gonna do now?
I don't know. Wait, I can use a substitution reaction. I'll just add heat and replace one of the hydrogen atoms with another atom or group of atoms.
My dilemma can be represented by this diagram. I'm like the NO2 inside the aromatic ring. By adding some activation energy in the form of heat, I can substitute myself for one of the hydrogen atoms and escape.
Perfect. Now I just need to catch Sigmund. I got my scooty.
Hey, what about us?
You're welcome.
Look at Carbon, chasing Sigmund up and down, but Sigmund's heading eastbound. So turn around.
Dude, why are you next to me? You're breaking all sorts of rules.
Wait, I know you.
Not one step closer, Bond. We have your girlfriend.
That's not my girlfriend.
Then we have a girl.
You monster.
My carbon crew has them firmly in their double bond.
Their double bonds are too strong.
And I'll just break them with addition reactions.
My bonds! How did she escape?
Everyone knows carbons love playing ultimate frisbee. Not so fast. You've been bonded.